two different ways that you can see this notation. So I'm going to write two different things here. You have, it's like an F, and then you'll see an open circle kind of in the middle. So it's not multiplication, it's literally an open circle, a G, and then an X. The other notation for this, these are interchangeable. F, and then a parenthesis, G, and then another set of parentheses around an X, kind of closed like that. So those are the two ways that this can be written. This is called composition. So this is F composed with G of X is how you would read that. Or F, sometimes people will read it, you don't have to write both of these, but F of G of X is another way to read that. So little open circle, that's going to be composition, it's not multiplication. And when I have F with the G in the parentheses, again, it's not multiplication, it's composition. So F composed with G of X or F of G of X. I'll probably say F of G of X. And these two things are interchangeable, so I'm going to try to use both today. All right, now, I'm going to give you a couple of functions, just like we did yesterday. This is basically like two problems in one when you work on this with numbers. All right, so I've got f of x. My function rule here is going to be the 5x plus 4. G of x is going to be this x minus 3. All right, so here's how this works. This first one says f composed with g of 6 or f of g of 6. If you like this notation, the one closer to the number goes first. If you want, the other notation for this would look like this, f of g of 6. All right, so if you were in that notation, we'll work from the inside out. So you're going to do two problems in one. We're going to figure out what g of 6 would be. So if I plug in 6 to my g function, what would I get? Anybody know? 6 minus 3, exactly. All right, so this is just 6 minus 3, which would be 3. All right, now here's the deal. It's like I was telling you a second ago, it's like two problems in one. Once you figure out what g of 6 is, that number gets substituted in place of that g of 6. So my actual answer to the question, we're going to end up plugging that answer we just got, which was 3, into the f of x function. And this will be my final answer. So I'm going to do 5 times 3 plus 4. That'd be 15 plus 4, so 19. And 19 would be my actual answer. You're just kind of like plugging one function into the other. It's two problems in one, kind of a two-step process. Now, if I look at the one next to this, whatever's closer in that notation goes first. The other way I could write this says g composed with f of negative 7. I could also write it as g of f of negative 7. Whatever's closer to the number goes first, or if you got the other notation inside out. So this one, we would do f of negative 7 and get a number. So just go up to your directions in the f of x function. Everywhere I see an x, I'm just going to put negative 7 in place of that x. And if you want, grab your calculator, or you could do it in your head. We're just going to simplify this. So what would that be? Negative 35 plus 4, negative 31. Okay, so I'm partially done. That is f of negative 7. Once you have that, then you plug that into the g function. So this is g of f of negative 7. Well, f of negative 7 is negative 31. So then I'm going to do the g function with negative 31 in it to get my actual answer. So that guy's just x minus 3. So negative 31 minus 3, I'm getting more negative, be negative 34 for my answer there. The last one, you can't actually compose a function with itself. We're just going to use the same function twice. So this says f of 8. So I'm going to plug 8 into the f of x function. Just real quick, everywhere you see an x, just replace it with an 8. So 5 times 8 plus 4. 5 times 8 give you 40. Add 4 to that, you're going to get 44. And then the only difference here between this one and the last two questions we just did, we're just actually going to plug that back into the same function. So to get my answer here, I'm going to do f with 44 plugged in. So again, I'm probably going to grab my calculator if I'm doing this. So if I do 5 times 44, I'm going to get 220. I'm going to add 4 to that. So my actual answer to the question is going to be 224. Is anybody having a question at the moment? It's kind of weird, but it's really just two quick problems within the same question. Composition. All right, so let me have you guys try these down here. Now, I have two different functions on this one. All right, so my f of x, we're going to bring our absolute values back here a little bit. So I have absolute value of 3x plus 2. And my g of x actually has a square root. I don't know if we've done anything with those this year yet, but square root of x plus 4. All right, so my first one, this is going to be g of f of negative 10. So I'm going to take negative 10 and put that into the f of x function. Remember, this is just notation. I'm not doing anything with that. It's not f times 10. It's f with a negative 10 plugged into it. All right, so I've got 3 times negative 10 in the absolute value plus 2. Now, anybody know how that, like, how would you simplify that? How does that work with the absolute value there? Makes it positive. So what would you have for that first term? 30. This 3 times negative 10 would be, you don't have to write this part out. This would be negative 30. Absolute value is going to make that positive, so it'd be 30 plus 2. So it's going to end up being 32. You do not have to write all that work out. Once you have that, we're going to grab this and we're going to plug it into the g function. So f of negative 10 equals the 32. So then we're going to do g of 32. All right, so in my g of x function, it's the square root, and all this is under the square root, the 32 plus 4. How do I do that? Do I take the square root of 32 and the square root of 4 and add them together, or how do I do that? Yeah. Yes. Okay, the square root acts like a grouping symbol. So whenever you have another square root, you want to get that down to one number and then take the square root. So add those together first to be square root of 36. Anybody know what that is? 6. Yeah, square root of 36. If you guys are using the graphing calculator, you're not familiar with it, the square root button is kind of right diagonal from the 7. That x squared button, you have to hit second, and then that x squared, I'm not even on the screen, but that'll give you a square root. Or maybe you just know square root of 36 is 6. The next one I've got here, sorry, I wrote too much work on that one. All right, I've got f of g of 77. So first one is going to go into the g function. So we're going to do g with a 77 plugged in. So that would be square root of 77 plus 4. What am I going to take the square root of? 81. Anybody know what that is? 9. Okay, good deal. Now, once you got the 9, we're going to plug that. That's what g of 77 is equal to. So to get my actual answer after my composition here, I'm going to do f of 9. Okay, now, in your absolute value, you just have 3 times 9. So after that, we would add 2. So 3 times 9 is 27. And in terms of an absolute value, if it's already a positive number, it's just going to stay positive. It doesn't change it to the opposite. So this would be 27 plus 2, and then my answer is going to be 29. All right, and I got one more, and I'm definitely going to grab my calculator for this one. Okay, so I have g composed with itself here. So g of 3,596. So to start that guy out, I'm going to plug that 3596 into the g function. So 3596 plus 4. Yikes, it's going to be square root of 3600. Anybody know what that is? It's a nice number, it's 60. Okay, once you get it, you're just going to plug that actually back into the same function because we're composing it with itself. So it's g of 60. So then I'd have 60 plus 4 under my square root. Anybody know square root of 64? 8. Good deal. Just some review here today with some square roots a little bit. Is anybody having a question? Okay. Now, this one is a little tricky at the bottom here. I am literally only doing this with you today because there is a bonus question like this on the test for this unit. I did not tell you that, but I just did. Okay, now, this is actually a composition of 3 functions. So this, we're just going to work inside out. I'm going to start and I'm going to do h of 2, and then I'm going to do whatever that number is I get, we'll do g of that. Whatever that number is, we'll get f of that. That'll be our actual answer. So this is just going to be 3 steps. So I'm going to start in the middle. H of 2, just look at your directions for your h of x function. We're going to do 2 squared plus 1. So 2 squared is just going to give you 4, plus 1 would give you 5. All right, once you've got that, then the next, like working inside out here, the next one is g. So I'm going to take 5 and plug that into the g function. And that's just 3 times x if you look at the directions. So, oops, sorry. 3 times 5 is going to give me 15. And then to get my actual answer to the question, the last function I'm going to put in there is f. So I just got 15, so I'm just plugging these in just as I go. F of 15 be 2 times 15 minus 1. That's going to give me 30 minus 1, so 29. That would be like a triple composition there. Just 3 functions. Yeah. No, I started to write 5 instead of 3. It's just 3 times 5 is what it should be. That's my fault. Okay, is anybody having a question with doing with this with numbers? Because I'm going to have you guys do this with variables on the back. Okay. Now, these are a little trickier. So just like operations, if we got a number, our answer is going to be a number. If we have variables, which is what I have here on the back, we are going to have variables in our answer. And you guys will notice I repeatedly wrote the same directions twice, but it's literally just so I can circle something for you. Okay, now this would be read f composed with g of x or f of g of x. All right, here's the deal with this. The g of x function is given to me in the directions. What you are going to do here, everywhere you see an x in the f of x function, you are going to take and replace it with that entire expression. So f of g of x is this x minus 3. So to do this, just take your f function. Everywhere you see an x, you're going to replace it with that whole expression, which is x minus 3. And then once you've done that, all you have to do, if you can simplify at all, you want to simplify. So there we could just do a little distributive property. So this would be 5x minus 15 and then plus 4. Just combine any like terms if you can. So this would end up being the expression 5x minus 11. So I'm taking the whole g of x function, just that expression, that function rule, I'm plugging it in for x in the f of x function. Okay, now I'm going to show you the difference here. The one next to this almost looks like it's exactly the same question, but in this one you have g composed with f. So this goes backwards. I'm going to take and plug the f of x function. I'm going to compose that with the g of x function. So what I'm going to do here, I'm going to take the 5x plus 4, and everywhere I see an x in the g of x function, I'm going to put that in place of it. Okay, now when you do this one's just a little bit it's just x. There's nothing to distribute or anything like that last one. So when I write this, I'm just going to kind of lightly write parentheses here, but I don't really need them. So 5x plus 4 is replacing that x, and then you have minus 3. I just have a plain x, so if you want to just think about dropping those parentheses, there's nothing to distribute, but I can combine like terms just a little bit because I can put the 4 and the negative 3 together. So the expression for my answer for that one is going to be 5x plus 1. So they are different. So if you do them in a different order, you get a different answer. Does anybody have a question at the moment? Okay. Now, I'm going to do kind of the same thing again, but one of these is a quadratic this time. All right, so this is f composed with g of x, or could write it as f of g of x. So when I compose these, I'm going to take the g of x function here, which is this whole guy, this x squared plus 2x minus 8. Everywhere I see an x in the f of x function, I'm going to substitute that in place of that. And then we'll just simplify if we can. So f of x is 3x, but instead of the x, we're just going to plug in, you got x squared plus 2x minus 8. And then the rest of that just had a minus 1 with it. So if you can, which we can for this question, we want to simplify. Just a little distributive property. So I've got 3x squared plus 6x minus 24, and then the minus 1 on the end. The only other thing you could do there, you can actually take and combine the negative 24 and the negative 1. That'll give you negative 25. And then that would be my answer to compose those two together. All right, now, I'm going to tell you up front, this next problem is the worst problem you would have to do in this entire unit. And it's the same two functions, but I'm going to go backwards this time. So this is g of f of x. The reason this is super tricky, I'm going to take the f of x function, which is 3x minus 1, and everywhere I see an x in the g of x, I'm going to replace that. The reason it's tricky is because I have two different places I would have to sub that in, because I have two different terms with an x in the g of x function. All right, so as you guys do this, try and leave yourself a little bit of space. This is x squared. So in place of x, I'm writing that 3x minus 1. That whole thing would be squared. Then you have plus 2 times x, and then in place of the x, I got to put that 3x minus 1 again. And then I've got the minus 8. Now, that very first piece, 3x minus 1 squared. You guys know how to simplify that set of parentheses. Like, do you know how to square this? 3x minus 1. Do we know how to square it? Okay, she says square the 3x and square the negative 1. On the right track. Does anybody know what's wrong with that? I'm only making a deal about this because nobody ever remembers this. Okay, here's the deal. If you square something, you can't, if it has adding or subtracting, you can't just distribute the squared, because when you square something, you multiply it by itself. So if I have 3x minus 1 squared, it really means 3x minus 1 times 3x minus 1. If you just distribute that exponent, you completely miss out on one of the terms that should be part of that as you simplify it. So just be careful. You can't distribute a squared or a third or any power if you've got adding or subtracting in the parentheses. You got to write it out twice. All right, so I'm just going to do this real quick. Foil or box, whichever one you like better, but that's what we got to do on that first term. So if I do 3x times 3x, we're going to get 9x squared. 3x times negative 1 is negative 3x. You're going to get that again. Negative 1 times 3x is negative 3x, and negative 1 times negative 1 is 1. I know that's a lot, but you'll see I get 9x squared minus 6x plus 1. I would have missed out on that minus 6x if I had just distributed the exponent, so it would make it a little bit trickier to work with. Okay, now, let me I did not bring down the rest of this, and I got to do that. So we're going to bring down the rest of this. I'm going to distribute this 2 up here, but I'm going to write it down here. So I've got plus 2 times 3x is 6x, 2 times negative 1 is negative 2, and then I also had this negative 8 up here. Once I've got that, we're just going to combine like terms. And on this particular question, kind of a little bit of a fluke or whatever, but you do have a positive 6x and a negative 6x, so those will add up to 0 and cancel each other out. And we're going to have a 9x squared, and then we're just going to put all our plain numbers together. You've got 1 here, minus 2, minus 8, so it would be negative 9 if you combine those like terms. That is the worst problem in this whole unit, is something like that, if you have to plug an expression into a quadratic. And it's not terrible, it's just a couple different things you want to remember. Does anybody have any questions? Okay, I'm just going to skip this last one because I feel like that was a lot for today. So we'll just skip that last example. So